Thanks to NordVPN for sponsoring today's video. Europa, one of the most exciting moons in the entire solar system. It is a beautiful world filled with mysteries. This is the first ever close-up image of Europa, taken by the Pioneer probe back in 1973. Since then, we've had the Voyager and Galileo probes explore the moon, and with each visit, Europa has never failed to surprise us. We are yet to solve a lot of Europa's puzzles, but there are many things that we are starting to piece together. I'm Alex McColgan, and you're watching Astrum. Stick with me in this video, and together we will explore some of those fascinating mysteries and delve into almost everything there is to know about this intriguing world. Let's first of all see where Europa fits into the Jovian system. Europa is the second and smallest of the 4 Galilean moons, although it's still the 6th biggest moon in the entire solar system, just behind Earth's moon, with a diameter of about 3,000 kilometers. It takes Europa 3.5 days to orbit Jupiter once. Interestingly, the first 3 Galilean moons, Io, Europa and Ganymede, are locked in a 4-2-1 orbital resonance due to their gravitational influence with each other. This means that every time Ganymede orbits Jupiter once, Europa orbits twice and Io orbits 4 times. This orbital resonance and the constant gravitational tugging from the other moons keeps the orbit of Europa from ever becoming completely circular. Due to Europa's slight ecliptical orbit, the magnitude of the gravitational force acting on it from Jupiter increases and decreases as it orbits. This creates tides that stretch the moon's surface. These forces are significant as they have a big influence on the moon's appearance and what goes on under the surface. Europa's surface is made predominantly of water ice. As you can tell, it looks very remarkable and distinctive due to these long, continuous fractures and cracks. These are called lineae, which translates to lines in Latin. These lineae are often only about 1 to 2 kilometers wide, but can extend for thousands of kilometers across the moon's surface. We aren't sure how or why these lineae are formed at present, but the most likely theory is that as the crust pulls apart from tidal flexing, warmer material from beneath fills the gap, in a similar fashion to the ocean ridges on Earth. In this image taken by the Galileo spacecraft, you will notice some dark brown spots. They are very small, only about 10 kilometers across, and they are known as lenticulae. They are also believed to be formed by the upwelling of hot, less dense material to the surface, either by pushing the existing crust up or by breaking through altogether. Should the underground material have broken through, what we can then see are these strange, unusual terrains called chaos terrains. They are really rough patches surrounded by a rather smooth surface. These spots are expected to be soft and may contain significant information about what's under Europa's surface, which we will get to later in the video. Data from Galileo also indicated that Europa's equator may be covered in icy spikes called penitentes. These vertical cracks may be up to 15 meters high and will have formed from direct overhead sunlight on the equator. Interestingly, penitentes are found on Earth too, in dry regions at high altitudes, although nowhere near as large as on Europa. Despite being roughly the age of the solar system, Europa barely has any craters. Europa has less than 50 major craters, whereas the Earth's moon has more than 5,000 craters with a diameter above 25 kilometers. This indicates that Europa's surface is constantly changing and reforming. Models suggest that Europa's surface is only about 30 to 180 million years old, which is very young in geological terms. Additionally, Europa's icy surface is the smoothest surface of any known solid celestial object in the entire solar system. Its icy crust also has an albedo or light reflectivity of 0.64, one of the highest of all the moons. Europa's albedo makes it 5 times brighter than our moon. The surface is bombarded by a constant and intense blast of radiation from Jupiter. The radiation level at the surface of Europa is equivalent to a dose of about 5,400 millisieverts per day. Exposure to radiation at that level would be enough to kill a human in a single day. The reddish-brown color spread across the cracks and fractures of the moon is believed to be due to salt and sulfur compounds mixing with water ice and then modified by Jupiter's radiation. A recent study from JPL suggests that Europa might even glow in the dark. Energetic ions from the radiation penetrates the surface, which would energize the molecules beneath, which would make them release energy as visible light. Unfortunately, we cannot see Europa's dark side from Earth, as we are between it and the Sun always. So we are going to have to wait for future missions to Europa before we can prove this. Radiation received from Jupiter plays a significant role in Europa's atmosphere as well. Europa has a very tenuous atmosphere, composed primarily of oxygen. Unlike on Earth, the oxygen on Europa is formed by radiolysis, or in other words, the process of radiation bombarding the water ice surface, separating the H2O into oxygen and hydrogen. Hydrogen escapes Europa's gravity altogether because it's so light, whereas a lot of the heavier molecular oxygen remains. The hydrogen and oxygen that escape Europa's gravity form a dispersed neutral cloud, which follows the orbit of Europa around Jupiter. In 2012, the Hubble Space Telescope discovered plumes of water vapor erupting from Europa's south pole. This image suggests that the water plumes rise up to 200 kilometers from its surface. In 2018, astronomers found additional evidence of water plume activity on Europa when they looked back at the old Galileo data with a new data analysis technique. A dedicated mission studying these plumes can also help us understand what's inside the moon without having to land on it. Because what may lie underneath that solid ice surface is perhaps the most fascinating thing about Europa. There is likely to be a global ocean between a rocky mantle and the water ice crust. The first clue that this amazing ocean world was hidden under its surface was provided by the Voyager and Galileo probes in 1979 and the late 1990s respectively. Between these missions, there was a drastic change in the magnetic field of the moon, which is not possible unless there is some electrically conductive fluid beneath its surface. Europa's crust also indicates the presence of a liquid layer beneath it, as it rotates with an angle of 80 degrees, which is not possible if the crust and rocky mantle were mechanically attached. Instead, it is likely that the icy crust floats on the ocean, and it is believed to make one full rotation around the moon once every 12,000 years. The fact that this ocean is not attached also explains the multitude of lineae on the surface. Tidal flexing should cause lineae to form at specific points on Europa, not all over. However, because the position of the crust changes over time, and one spot never stays in the same place for long, hence why more and more lineae form. Europa is 780 million kilometers away from the Sun, which is 5 times further away than the Earth. That makes the sunlight about 25 times fainter here. As such, Europa, or any other moon in the Jovian system for that matter, barely receives any heat from the Sun. So unsurprisingly, it's cold enough here that the surface is frozen. In fact, Europa's surface temperature averages about minus 160 degrees Celsius at the equator and minus 220 degrees Celsius at the poles, keeping Europa's icy crust as hard as granite. However, tidal pressures exerted on the moon as it orbits Jupiter heats Europa's core, so geothermal activity from the core should keep the subsurface ocean in a liquid state. This ocean is believed to be under only 15 to 25 kilometers of solid frozen crust. The ocean itself is probably about 60 to 150 kilometers deep. Interestingly, Europa is only 1/4 the diameter of Earth, although it may contain twice as much water as all of Earth's oceans combined. What's most interesting about Europa's ocean is that scientists believe that it is in contact with Europa's silicate rocky mantle. This makes Europa's ocean a suitable environment for life as we know it to exist. We believe that life requires water, minerals, and energy to form, and Europa seems to have all these requirements. From the evidence we've seen so far, scientists are extremely confident that this ocean not only exists, but that chemical reactions can take place there, and that there is enough tidal energy heating the core that geothermal activity may exist on this ocean's floor. As we have seen on Earth, whole ecosystems can exist in such places, far from the sun's light. So for now, Europa is one of the most likely places we can find life outside of Earth. Now, NASA's Europa Clipper spacecraft is scheduled to launch in 2022 and is likely to reach the moon by the end of the decade. It is scheduled to perform more than 42 flybys of Europa. ESA is also working on their own spacecraft called JUICE, or Jupiter Icy Moons Explorer, which will explore Jupiter and 3 of its largest moons, Ganymede, Callisto, and Europa. JUICE is also scheduled to launch in 2022 and is also likely to reach the moon by the end of the decade. These probes are specifically designed to examine Europa's water plumes and atmosphere. NASA is also planning a Europa lander mission, but this mission is going to launch well after the Europa Clipper mission. These missions will help us know more about Europa and hopefully confirm the answer to the most tantalizing question of all: does it and can it sustain life? At the very least, these missions will give us a new perspective of our solar system and help us understand how it works. So there we have it, almost everything you could want to know about the fascinating world of Europa. Another Christmas event I'd like to draw your attention to is the NordVPN Christmas deal. Over this Christmas period, NordVPN are running a deal where you can sign up to their 2-year plan for 68% off, plus 4 additional months absolutely free. NordVPN is a service that allows you to browse the web safely and securely, as if you were in pretty much any country in the world. The advantages of this are that you no longer have to worry about making a purchase online while on a public network or on your mobile data, because NordVPN encrypts all the data you send and receive. And if you are abroad, but still want to access region-locked stuff back home like Netflix or Amazon Prime, NordVPN has you covered, allowing you to log into the internet as if you were in almost any country. You can use NordVPN on your phone, desktop, or laptop with up to 6 simultaneous connections. So take advantage of their Christmas deal with the link nordvpn.org/Astrum and use the coupon code Astrum at checkout, and you can get 68% off their 2-year plan. And for a limited time, get 4 months for free. Thanks for watching. If you enjoyed this video about Europa, be sure to like and subscribe, and also check out some of our other solar system's moons in this playlist here. A big thank you as well to my patrons and members who support the channel. If you would like to support too, check out the links in the description below. All the best, and see you next time.